Alright, if I were to multiply this out completely, I would get this, and this is the degree of the function. Also, I can look at it and say, well, I've got x squared there and an x there when it's factored, and I can also say that that is also a 3 because 2 plus 1 is the 3. To figure out where the roots are, I simply set each factor equal to 0. And then I solve. So this one here is easy. I set this equal to 0, I get 3 as my answer. That is totally real, dude. And for this one here, when I set this one equal to 0, I square root and I get x is equal to plus or minus 2i. So I get 2i and negative 2i, and those are totally complex. So those are my complex roots, and that is my real root. Let's go ahead and also look at 12 and 13. We're just going to do all of these together in one video. The degree of this one, this is my highest power here, and here, and here, and here. So I have 2, 3, 4, 5. So this is a 5th degree. How do I know? I look at all of my leading x values, and I simply add them all up. And to find all the roots, when I set this equal to 0, I get 0. When I set this equal to 0, I get negative 2. When I set this equal to 0, I get 1. And when I set this equal to 0, I need to actually solve for it. Now, I can't factor it. I've got 5 and 2, and nothing works for that. So I do have choices. I can either use quadratic formula, or I can complete the square. I like completing the square. It ends up being a lot easier in this case because I have a 2 there, which is nice and even. So I divide by 2 and square, I get 1. So I factor this. I have x plus 1 squared equals, this is negative 4. I square roots. I get x plus 1 equals plus or minus 2i. So my answer is negative 1 plus 2i and negative 1 minus 2i. So those are both complex, whereas those are both all 3 real. So I have 1, 2, 3, 4, 5 roots for my equation.